STEM people, and this is STEM 2.9 today. We're continuing on naming our chemical formulas and writing chemical formulas, and this episode is all about molecules. Now, the difference between a molecule and the ionic compound is that the molecule is made up of covalent bonds, and we do not reduce the subscripts. So we have something a little different. We're not going to reduce this time. And the way that we know how many atoms there are is going to be based on this nice little series of prefixes that help us determine the number of atoms. So we're going to name these molecules, and let's look at these prefixes here in just, oops, that's not a erase, in just 1 second. Let's see what happens. Oops, come on, let me go. There she goes. Okay, and there's those prefixes I was talking about. You notice that we have, let's click so Mr. Arnold could be up front so I can really get a good look at that, right? So you see that we have mono means 1, di means 2, tri 3, tetra, penta, hexa, hepta, octa, nona, deca. You do not have to memorize these. These will be on a list for you, and actually they're on the back of the world famous ion chart. They're back there in the corner. Again, my camera makes it upside down, but they're there. Okay, so we need to use that to figure out or see how many atoms there are. I am going to start down here with this P2. See it? P2O5. P2. We know that means there's 2 P's. We know there's 2 P's, right? And we also can use our chart and find out that P is phosphorus, right? So if we have 2, low battery here. If we have 2, let me plug in while I'm talking. That means di, right? 2 is di. So di, and then phosphorus. Okay, that's the first name. Now, notice I didn't write phosphide. If it's the first thing listed, we use the regular element name, and phosphorus is the regular element name. First name, always regular name. Second name, always going to be that I name. Okay, so diphosphorus. And then we have oxygen, and we have 5 of them, but that's the second listing, right? That's the negative. Normally the negative, in this case, it really is not supposed to have a charge, but it's the second thing listed, so we end that in "ide." So we're going to say pent oxide. Now, this gets a little weird because you got pentaoxide or pentoxide, and to make things simpler, let's do it the simple way. And let's just, get back here. And let's just put pentaoxide and put an A in there, and we'll put a slash so it looks more like our chart. How's that sound? All right. So diphosphorus, you know what? To make it simpler again, let's put a dash between that, just to keep it separate, to realize what we have. The most important thing is going to be writing the formulas, and I think this will make it easier if we write the names this way too. Okay. All right, so that's pretty much what you do. Now look at this, the first one. We have 1 sulfur, and we have 3 oxides. So I'm going to do this, and I'm going to tell you what I'm doing wrong after I do it. We have mono, sulfur. I'm going to change that size of that pen again. I don't know what I changed it to. So mono, sulfur, right? And then trioxide. Okay, now that's what we'd think it would be. Now, there's a little weird exception to the rules. And it's only for this mono, and it's only for when it's the first thing listed. So this only goes for the first thing listed. The mono there is not needed. Remember when we talk about chemistry, how ones aren't used? Well, here's a good example. They figure if you're going to say sulfur, you must have at least 1. And so you just say sulfur trioxide instead of monosulfur trioxide. Just one of the little weird things of chemistry. that is hard to get used to. Let's just go fast now. Again, there's only one carbon there, so we're just going to write carbon. And there's 4, so 4 is tetra. And again, it has to end in the "ide," so that's fluoride. Oops. That looked weird. Okay, so nitrogen. I've switched into cursive mode for some reason. And then we have and then we'd say dioxide. And I'm putting a slash in. Remember, I'm only using slashes to make it more easier to see these things. We have iodine. It's the first thing listed, so you don't say iodide. It's going to be iodine. And I'm still in cursive, I guess. And trichloride. So there's that last name always ending in "ide." And now this last one, I know you know this. Carbon, right? We don't need the mono because it's the first thing listed. And then dioxide. Bing, bang, boom. There we go, right? So that is just the naming. Now, the naming's not that important to us, except in this chapter, because, you know, we just want you to be able to see these names and figure out what's in them. So let's try here. Carbon tetraiodide, so carbon is C, and there's nothing listed there, so there's one of those. And then tetra means 4, right? So tetraiodide, so that means we have I4. Nitrogen is N, and again, I'm just giving these off the table, I know them. And then monoxide, monoxide. So we put an O here. Right? Phosphorus trichloride, sulfur dioxide, dinitrogen, 2 of them, tetraoxide, and dihydrogen monoxide, and there's water again, and that brings this episode to a close. So I'll have about 10 of these, 12 of these on a sheet of paper for you guys to practice, and that'll be your last formula note. All right, thanks a lot. Have a good day.